Hello mathematicians. Today I'm going to help you with a few IB logarithms questions from standard level and higher level. But if you are confused, remember to watch the previous videos uploaded earlier on the concepts of logarithms. But before we get started, don't forget to like, share and subscribe to our channel and press the bell icon to get future notification for our new videos. Let's get started. So let's look at how to do this question. In this question, we are given that this can be written in form of px plus qy, and we have to find the value of p and q. So before we get started, let me tell you a rule. If we have log of x over y, log rule says that when they are in division, we can just simply subtract it. So log x minus log y. Now we can use this rule here. Keep this in mind. So we have log 2 of 32 to the power of x over 8 to the power of y. So log 2 of 32 to the power of x minus log 2 of 8 to the power of y. Now we can write 32 and 8 in the basis of 2. You will see why that will be helpful. So if we do that, we'll have log 2, and 32 is 2 to the power of 5. And don't forget the x. And log 2, 8 is 2 to the power of 3. And obviously don't forget the y there. Now log base also says that if we have a power, we can bring it in front. So 5x log 2 of 2 minus 3y log 2 of 2. So log 2 of 2 can just simply be written as 1. So 5x minus 3y. So we have also written it in the form of px plus qy. And we know the value of p and q, which is 5, because 5x in front of x is p, and in this case in front of x is 5, and q is equal to negative 3. Don't forget the negative there. So this is our final answer. Let's look at how to do this question. In this question, we are given that log base a of 2 is equal to 5, and we have to use this information to solve for log base square root of a 2. So before we start, let's revise an important rule, which says that when you have a power in a log base, then you can just bring it to the front here, but you have to reciprocate it. So 1/2 will become 2. Simply we'll have log a 2. We'll be left with that in this case. So remember this rule, it will be helpful here. So we have log square root of a 2. We have to solve for this. So we can write square root of a as a to the power of 1/2. And using this rule here, we can bring 1/2 to the front and it will reciprocate and become 2. So we'll have 2 log a 2. Now we can just simply substitute 5, because log a 2 is equal to 5. So we'll have 2 times 5, which is equal to 10. So our final answer is 10. In this question, we have to solve for x given this equation. Firstly, what we will do is we will turn the 9 in the base of 3. You will see why that will be helpful. 3 squared is 9. Now we know that exponent rule, that when we have an addition in the exponent, we can just multiply it like this. And then we have -5 here. So then let's simplify this. 2 times 3 is 6. So 6 times 3 to the power of x. And let's bring the 5 to this side as well. Plus 5 equal to 0. Now I'm starting to see a quadratic equation, because a variable squared is equal to 6 times that variable plus a constant. So to make our calculations easy now, let's assign 3 to the power of x a variable. Let's say a. So a is equal to 3 to the power of x. So now substitute a, and we'll have a squared minus 6a plus 5. So we'll use the middle term break method to solve for this now, we have to find two numbers that add up to make -6, and the same two numbers need to multiply to make +5. So what can be those two numbers? Let's say 5 and 1. So 5 times 1 is 5, which is good, but 5 plus 1 is not -6. So we'll make them negative. So now -5 times -1 is equal to 5, and -5 plus -1 is equal to -6. So we will use the middle term break now. So we have a squared minus 5a minus a plus 5. Now we can factorize this. We will be left with a minus 5 minus 1, a minus 5 is equal to 0. So we can write it like this, a minus 1 and a minus 5 is equal to 0. Now we can keep this equal to 0 and this equal to 0. So we'll have a minus 1 equal to 0 and a minus 5 equal to 0. Now our values are a is equal to 1 and a is equal to 5. But we're not done here because we have to solve for x, not a. You remember that we gave 3 to the power of x a variable a. So now instead of a, we can just simply replace 3 to the power of x equal to 1 and 3 to the power of x equal to 5. Now we can use log rules to solve for x. So if we use log rule, we'll just be left with x equal to log 3 of 1 and x equal to log 3 of 5. So our answers for x is this. Let's look at how to do this question. In this question, we are given that 14 to the power of 6x is equal to 64 to the power of x plus 3. We have to solve for x in terms of ln2 and ln7. Let's get started. So 14 to the power of 6x is equal to 64 to the power of x plus 3. Now, let's split 14 and 64 in terms of 2 and 7. You will see why that will be helpful. So we can just write 14 as 7 times 2 and then 6x, and 64 is simply just 2 to the power of 6. It's 2 to the power of 6 x plus 3. Now we can simplify this further. We can put this into two different variables and then we can use the distributive law to multiply this. 6x plus 18. Now let's take the 2 to this side to simplify this further. So we'll have 7 to the power of 6x, 2 to the power of 6x plus 18 over 2 to the power of 6x. The exponent rule says that when two numbers are in division and have the same base, we can subtract the exponents. We can write this like this. And then simply 6x and 6x can cancel out and we'll be left with 7 to the power of 6x is equal to 2 to the power of 18. Now let's apply ln to both sides. So now you see that applying ln was actually helpful because we want to find in terms of ln2 and ln7, and that's why we had to split 14 and 64 into 7 and 2. Now we know the log rule says that when there's an exponent, we can bring this in front. So 6x ln 7 equal to 18 ln 2. So we're left with 6x ln 7 equal to 18 ln 2. Now we can take everything to the other side to find x, but leave the x on this side. So we'll have x is equal to 18 ln 2 over 6 ln 7. And 18 divided by 6 is just simply 3. So our final answer is 3 ln 2 over ln 7. So we have found the answer in terms of ln 2 and ln 7. Let's look at how to do this question. In this question, we have to find the value of a and b given this equation. So before we start, we have to revise an important rule, which is the change of base rule. When we are given something like this, we can change the base and write it like so. We can use this over here. You will see. So we are given a plus b log 4, 7 plus 60 log 8, 14 is equal to 0. So a plus b. Now we can apply the change of base here. Log 7 over log 4. So our bases are just 10 in this case. Then we can apply this here as well. Log 10 over log 8 equal to 0. We can change 4 and 8 now in bases of 2. You will see why that will be helpful. So a plus b log 7 over log 4 is just 2 to the power of 2. 60 log 14 over log 8 is just 2 to the power of 3 to 0. So we'll be left with a plus b log 7 over 2 log 2 plus 60 log 14 over 3 log 2. I just brought the exponent to the front here. Now we can take log 2 as an LCM. So if you do that, we'll have a log 2 plus b over 2 log 7 plus, and then 60 divided by 3 is just simply 20. So 20 log 14 equal to 0. Now if we take 2 to that side, it will just simply be 0. So we'll be left with a log 2 plus b over 2 log 7 plus 20 log 14 equal to 0. So let's split the 14 into 2 and 7. So we'll do that like this. Log 2 plus b over 2 log 7 plus 20 log 7 times 2 equal to 0. So if we simplify this further, we'll have 20 log 7 plus log 2, because this is using the log rules. Now we have a log 2 plus b over 2 log 7 plus 20 log 2 plus 20 log 7. Now you see why splitting 14 into 2 and 7 was useful. We can take these two common, and similarly we can take log 7 as common. So if we take that as common, we'll be left with a plus 20 log 2 b over 2 plus 20 log 7. So we have a plus 20 equal to 0, because we just took 2 to this side, which became 0. So a is equal to negative 20. Similarly, we can do this here. B over 2 plus 20 equal to 0, because we took 7 to that side, so it will be 0. So b over 2 is equal to negative 20, and then multiply 2 to that side. So b is equal to negative 40. So our answer is a is negative 20 and b is negative 40. So now we have done some difficult problems on logarithms. If you have any concern, please comment below. Thank you for watching my video. See you next time.